I found a nice report by NASA in 1980s that actually they prove that some plants can absorb the VOCs. They didn't have acetone in their report, so I thought maybe I should find a plant that can absorb acetone.
I test the plants. We put them in the sampling chamber. It's usually a 12-hour process that we go through. So I'm in the lab with my partner, Jeffrey Peterson, for those 12 hours, experimenting with the plants, collecting the data, analyzing.
We set up the instrument here in the lab and all the sampling devices. So we thought maybe instead of acetone, we can look up other VOCs as well. So we picked the most dangerous VOCs and the most common VOCs and tried those with the most popular plants in our area. We tried those and we repeated the experiments until we got to the conclusion that what plant is good for what VOC.
Coming up with the experimental design, we had to come up with a way. We wanted to see how these plants reacted to these different VOCs, these different compounds. So we had to come up with a way. How are we going to sample it? How are we going to analyze it? So just thinking through the process and then getting into actually doing that. It was challenging, but it was also it was a lot of fun coming up with the experimental design.
I always recommend my students you need to see what you learn in class in the lab, in the real world, do the project that's related to what you're learning. And later, when you get a job, you will see that you are going to do the same thing that you are doing in the lab.
I started doing the research when I was a junior, and I knew that I wanted to pursue a career in the sciences, whether it was biology or chemistry. I had no idea that it would be analytical chemistry though, and this project has really gotten me on that path to the point where I'm already continuing just going into the field of analytical chemistry. So it really opened up my mind and geared me towards what I wanted to do in the future, even after I graduate